This is the video for Mod 9 Lesson 3B, Solving with Similar Triangles. In this video, we're going to be looking at using the theorems from 3A and using it to solve. So we're going to apply the properties of similar right triangles to find a missing length. So first we have to determine if they're similar, the triangles, using either one of the postulates or they give us a statement. We're going to write the corresponding sides as a ratio to find the scale factor. And then we're going to set up a proportion and solve, and then substitute back in if we need a given length for the triangle. In the first example, we actually know they're similar because they gave us a similarity statement. We obviously know the vertical angles are going to be the same. And then they tell us angle G pairs with angle S. So I might mark G and S the same. And then T and H are the same. So we always want to mark up our diagram so we're matching up the right pieces. The goal is to find the length of FT. So I'm going to call FT X because I don't know what it is. And it just so happens FT, which is between the 1 and the 3 tick marks, that's going to pair up actually with 56. And then we then can, conclude that those other two segments are going to match up. And so what we're going to do is we're going to write a proportion. So when we write this out, I see X is going to pair with 56. So we're not saying it equals 56, but we know whatever that ratio is, it's going to reduce to be the same thing as 39 over 91. Notice I'm picking values from the same triangle to be on the same part of the fraction. So the triangle on the left, I'm choosing to be on the top. I'm doing the same for the bottom. And now what we're going to do is we're just going to simply cross multiply. So we're going to solve a proportion, maybe like you remember back from middle school. So this is really just kind of using what we call the means extreme product theorem. So we're going to multiply, basically we multiply x times 91. So we get 91x. And that's going to be the same as multiplying 56 times 39. It's actually the same as if I multiplied both sides by 56. So again, I'm just like solving, this is a proportion, and I'm just cross multiplying. So when I multiply that out, I end up getting 2,184. So those multiply and they get the same value on each side. And now it's just a one-step equation that we're going to multiply out. And we get x to be 24. So what that means is the length of FT is 24. In the next example, we're doing basically the same thing. So they give us a similarity statement already. So I can see like LK pairs with TU. And then obviously we only have one other value, so we can see the 15 pairs with the 25. And the goal is to find X and substitute it back in for LK. So we're going to do the same thing. I'm gonna match up my corresponding sides. So I see the X minus 3 is going to pair with the 15. We then see the 15 pairs with the 25. Notice again, values from the same fraction are in the same, or values from the same triangle are in the same part of the fraction. I'm going to put a parenthesis around the x minus 3 so I remember to distribute. And we're going to go ahead and cross multiply. So do the same thing. So on this part, and I'm going to do this part, so we end up with 25, and I'll actually write it over here, 25 times x minus 3 equals 15 times 15, which is going to end up 225. And then we can distribute and solve. So the rest is just solving a linear equation. So we get 25x is equal to 300. Or when we solve it, we're going to get x is equal to 12. That's not the end of the problem. So LK is x minus 3. So when we substitute it back in, you're going to get LK to be 9. The last problem is very, very similar. So the only thing is these are overlapping. So if these are parallel lines, I know the angles are the same. We're going to match up our triangles. And I could actually even pull them apart if I want to, if that makes it easier. Really, once you kind of get the hang of it, you're going to find it's like the same thing over and over. So the small triangle, this is a 12 and an 18. The bigger triangle, and again, same thing marked, is going to be a 16 and a 10 minus 2x. And then we're just going to match everything up. So you see the 12 pairs with the 16. The 18 pairs with the 10 minus 2x. And then we're just going to cross multiply. So when we go ahead and do that, 10 minus 2x, 18 times 16 is 288. And then we're just going to go ahead and solve it out. And so this would be 168, and then we would divide. And so our final answer for this, we would actually get -7. And then when we substitute it back in, 10 plus 14 is 24. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.